Welcome back to our restoration of everyone's favorite 80s robot, the Hero Jr. You'll recall that last time something strange happened during the power-up start test.
Testing block 3. Testing.
This seemed to be the computer restarting itself, and it actually happens again just moments later.
Version 1.5. Checking. Version 1.5. Checking memory.
So something is causing the computer to restart, but what could it be? A while after the test AC issue, I was trying the sonar measurement, and here's what happened. Measuring distance, while you hold down the robot's enter key, press and release the 0 key, the robot will say Robot Wizard, enter F57B.
Robot Wizard. F57B. Press enter to confirm. Enter.
So we seem to be having a keyboard issue, and it only got worse. I should explain that the Heathkit robots were sold as kits to be assembled at home by their owners. This could result in some questionable solder joints, but even after 40 years, the best work could use a touch-up. So it's clearly time to fix the keyboard. The membrane keyboard and the LED display are housed in a single circuit board inside the head. First, we remove the body panels. Then the head is held in place with 4 wing nuts, one of which is guaranteed to fall behind this circuit board. Lifting the head up, we remove a variety of cables. And finally, we can place the head upside down on a soft cloth to protect the surface. To access the board, we first remove the front metal support, which is also home to the infrared motion detector we'll be fixing later. Lastly, 4 screws hold the board in place. The keyboard's held on with tape underneath of the contacts, which will clean with alcohol. The LEDs are unusual in that they're soldered on top of the board, but easy enough to take out. Then we clean up the holes with solder braid and the pins with a soldering iron. Straighten them, and then test each one to make sure it lights. Ready to go. I'm taking my time with this first one to make sure I can get a good strong set of solder joints, and then it's just a matter of repeating and keeping them all in line. Next, a test fit to see how well I lined things up, and then I'll check each one using the harness to make sure they all light. The green power LED is reverse wired compared to the others, but swapping the wires and it lights up fine. Clean off whatever flux might be there. Some more isopropyl alcohol to clean dust off the membrane, and once it's reassembled, it works like new.
Robot Wizard. F57B.
Next up is a strictly mechanical repair. The drive wheel seems to have a bit of a wobble. The wheel bracket is connected to the steering servo motor with a pair of set screws. Actually, one of them is a set pin and goes through a hole in the output shaft, so the wheel can get loose but never fall off. Turning these was very difficult, so I decided to rethread both the holes and the pins. And as you can see, they definitely needed it. After reassembling, the set screws hold great, but something is still loose. It turns out it's the gearbox for the stepper motor, so time to take it all apart again. With the gearbox out, we can tighten these 4 bolts on the corners and put it all back together again. Final result? Much better than before. With those repairs out of the way, we can move on to the main event, fixing the passive infrared sensor, also known as the IR motion detector. Recall that we saw the sensor briefly when we were fixing the keyboard earlier. The device is a fairly large metal package with a Fresnel lens that focuses light from the outside world onto a pair of infrared detectors. Imagine one on the left and one on the right. If we put a warm static object in front of the sensor, both the left and right sides will produce a peak. But because they're equal, this will indicate no motion. Instead, if a warm object moves from one side to another, we'll get a peak on one side and a flat response on the other, indicating motion. We can sum this up with the truth table. No objects on either side equals no motion. Objects on both sides equals no motion. But an object on one side and no object on the other indicates something moving. Here is the sensor from the Hero. This rightmost pin is supply voltage DC common, also known as ground. The analog voltage out is not used on the Hero Junior. The supply voltage 6 volts to 18 volts is the power in, and on the Hero this is supplied with 12 volts. And then the digital voltage out is where we should be seeing some sort of indication of whether or not we have motion on the sensor. This Fresnel lens is what's picking up the motion, and it's focusing it onto this kind of rectangular sensor face back here. And here on the connector we will have green is ground and red is blue for power. So between ground here and signal there, I'm reading 1.1 volts. And this is what I seem to get when there is no motion. So you see when I move the actual meter, I'll get a pulse of motion. Okay, there's my 1.1, and it stays steady unless motion goes through. I can cover here, and if I stay steady, it will eventually drop back down. And then if I move a little, we get a pulse. And then when the motion stops, we drop back down. So we get a pulse anytime there's motion, not just anytime something's in the field of view. So it is a true motion sensor. And according to this, assuming that voltage is a 1.1 volt for no motion and 4.5 for motion, this should be working correctly. So why does it not work in the Hero? All right, so another quick test. I just took the plastic film that covers the vent window on the front of the Hero Junior, and I've laid it over the sensor just to make sure that it actually is transparent to infrared, and it is, still functions. So, either we're not producing enough voltage, but it really feels like the output of this is scaled to 5 volts, or something on the power sense board is not delivering that signal correctly to the CPU. The signal from the PIR sensor goes through a single component before arriving at the computer, a quad 2-input NAND gate with Schmitt triggering. The Schmitt trigger compares the PIR to a constant voltage and outputs either a 0 or a 1, essentially digitizing the variable input. That particular Schmitt trigger lives here on U304, along with 3 others for the Sense Enable, Sonar, and Wheel Encoder. While I wait for the internet to provide a replacement, let's go ahead and do some cleanup work on the PIR window. The internet has provided. Let's install the Schmitt-triggered NAND gate and see what happens.
Checking motion detector. Please wave your hand in front of my motion detector. Motion detector. Okay.
And there you have it. The motion detector is working, and we have passed the power on start test. Before we go, let's circle back to the distance measuring program we were trying to run when we had the keyboard problem. The Hero Junior has a Polaroid sonar sensor on its face. and a program in ROM that reads and speaks the distance measured by the sensor in inches. That routine is located at memory location F57B, and to run it, we simultaneously press the Enter key and the 0 key, which Heathkit, in an attempt to sound friendly, I suppose, calls the Robot Wizard.
Robot Wizard. F 5 7 B. Press Enter to confirm, or C to change. Enter 71.2 11.6 5.9 25.5.
As you can hear, the routine just runs in a loop, measuring the distance and announcing it with the voice synthesizer. If you listen carefully, you can hear the chirping of the sonar firing in small bursts between each announcement.
4.3 4.3.
The device has a minimal distance, so any measurement under 5 inches repeats the same incorrect value.
3 4.8 5.4 10.1.
Now that we have a fully functional robot, in our next video we'll take a deep dive into the built-in software and find out just what Hero Jr. can do out of the box. Join us next time as we continue our restoration of everyone's favorite 80s robot. And if you like this video, don't forget to
like, subscribe, and ring the bell.